Hello students, I am Garvina Bhumik from Techno India Group Public School. Today I will discuss about solution of exercise 6.4 from the chapter triangle. So let us start with question number 5. In this video I will discuss about question number 5, 6, 7, 8 and 9. So let us start with question number 5. DEF at the midpoints of the side AB, BC and CA. You have to find the ratio of area of triangle DEF and ABC. That means you have to find the ratio of this triangle and the whole triangle ABC. Okay, so let's check the solution. Here is the solution. D and E are the midpoint of AB and BC respectively. So you can use midpoint theorem, which you have studied in class 9, and you can state that this DE will be parallel with this AC line and this DE will be half of AC. Okay, if you remember the statement of midpoint theorem, you can use that theorem and you can conclude that this DE is parallel to AC and DE is equal to half of AC. Now if you take this BED triangle, that means this triangle, if you take this BED triangle and the whole triangle BCA, okay, you can say that this E angle will be equal with this C angle. Why? Because they are corresponding angle. Okay, this one is parallel to this one. That's why this is this is equal to this one, because they are corresponding angle. Similarly, you can state that BDE angle will be equal with BAC angle. Why? Because again they are corresponding angle. Okay, these two are parallel. If you consider BA as transversal, you can say that this one will be equal with this one. So this is equal to this one and this one equals to this one by corresponding angles. Okay, so since two corresponding angles are equal, so you can say that by AAA similarity, this triangle BED will be similar with triangle BCA. Okay, that means this whole triangle, okay, this BED triangle will be similar with this whole triangle BCA. Now since they are similar, so you can say that the ratio of their area will be equal to square of their corresponding sides. Okay, square of ratio of their corresponding sides. So area of BED by area of BCA is equal to DE by AC whole square, right? Because DE and AC are the corresponding sides of BED and BCA triangle. Okay, again DE is given as half of AC. So in place of DE square, I am writing half of AC whole square. Okay, so it will be 1/4 AC square. Okay, so this AC and AC will cancel to each other. Answer will be 1/4. That means area of BED by area of BCA is equal to 1/4. So you can write area of BED is equal to 1/4 into area of BCA. Okay, that means area of BED is 1/4 of the area of the whole triangle. Now if you take the area, if you consider the area of whole triangle as x, and since this one is 1/4 of whole area, this was 1/4 of the area of the whole triangle, so you can say that area of BED is equals to 1/4 of x. Okay, in place of area of ABC I am writing now x. Similarly, you can say that this is means you can prove that this CEF is 1/4 of whole triangle ABC. In the previous slide I have proved that this one is parallel to this one. Okay, now E and F is also the midpoint of BC and AC. So if you take this E and F point, if you again use the midpoint theorem, you can say that EF is parallel to AB and EF will be half of AB. So in this way you can say that this one will be 1/4 of x, and also you can prove that this one is 1/4 of x. Okay, Now this area of DEF, okay, is equals to area of ABC minus area of BET minus area of CEF minus area of DEF. Okay, so let's check this statement again. Okay, area of DEF means this one equal to this whole area of ABC minus this part minus this part minus this part. Okay, so that is what written here. Okay, area of DEF is equals to area of ABC minus area of BET minus area of CEF minus area of ADF. Now area of ABC is considered as X, area of BET is considered as 1/4 of X, this is also 1/4 of X, this is also 1/4 of X. So I am putting the value. Okay, so after calculating the value of area of DEF will become 1/4 of X. Okay, so again the area of DEF is equal to 1/4 into area of ABC. X means area of ABC, so you can take this area of ABC in the left hand side. So area of DEF by area of ABC is equal to 1/4. So the ratio is 1:4. In this way you have to solve question number 5. Now question number 6. This is question number 6. Prove that the ratio of area of two similar triangles is equal to the square of ratio of their corresponding median. Here ABC is a triangle and PQR is a triangle. They are similar to each other. You have to prove that the area of ABC triangle, the ratio of area of ABC triangle and PQR triangle is equal to square of their corresponding medians. That means it will be equal to AD by PS whole square. AD and PS are the median here. So here given that ABC is similar with PQR, AD and PS are the median. Okay, now since ABC triangle is similar with PQR triangle, so the ratio of the corresponding sides will be equal. That's why AB by PQ is equals to BC by QR is equal to AC by PR. Okay, also since they are similar, their corresponding angles will be equal. So angle A is equal to angle P, angle B is equals to angle Q, angle C is equals to angle R. Okay, now AD is the median on the side BC. That means you can say that BD is equals to half of BC, right? BD or DC is equal to half of BC. Similarly, you can state that since PS is the median on QR, so this QS or this SR is equals to half of QR. Done? Okay, so if you take this equation number 1, okay, in place of BC by QR you can write half of BC by half of QR. You are multiplying both the denominator and the numerator by half, and in place of that half BC and half QR you can write BD by QS. Okay, so the equation number 1 transformed into equation number 3. So what is equation number 3? Equation number 3 is AB by PQ is equals to BD by QS is equal to AC by PR. The equation number 3, I am getting AB by PQ is equal to BD by QS is equal to AC by PR. That means AB by PQ is equal to BD by QS is equal to AC by PR. Okay, now if you take this ABD triangle and this PQS triangle, okay, then since ABC was similar with PQR, this B angle was equal with Q angle, corresponding angle, and from equation number 3, AB by PQ is equals to BD by QS if you take the first two ratio of equation number 3. Okay, now since one corresponding angle is equal, corresponding angles are equal, and the sides involving that angle, increase in that angle is also in the same ratio, So you can say that ABD triangle is equal with PQS triangle by SAS similarity. Okay, so this ABD triangle is similar with PQS triangle. Okay, now since they are similar, again the ratio of the corresponding sides will be equal. That means AB by PQ is equal to BD by QS equal to AD by PS, because now in these two similar triangle, the corresponding sides are AD and PS. Okay, that's why AB by PQ is equal to BD by QS is equals to AD by PS. Okay, now okay, now area of ABC and area by area of PQR, the ratio of ABC triangle by PQR triangle is equal to square of the ratio of the corresponding sides. That is, area of ABC by PQR is equal to AB by PQ whole square, BC by QR whole square, AC by PR whole square. Okay, now if you combine equation number 1 and 4, okay, this is equation number 1. Look at here, AB by PQ was equal with BC by QR is equal with AC by PR. Okay, AB by PQ was there. Okay, again if you check equation number 4, AB by PQ is also there, but now the ratio is BD by QS and AB by PS. So if you join equation number 1 and 4, you can say that AB by PQ is equals to BC by QR is equals to AC by PR is equals to AD by PS. Here is AD by PS. This one is equal to AB by PQ. That's why in this whole ratio you can add AD by PS also. Okay, that means area of triangle ABC by area of triangle PQR. In place of AB by PQ whole square, you can substitute BD by PS whole square. Okay, that's why area of ABC by area of PQR is equals to AD by PS whole square. Okay, that means the ratio of two similar triangle is equal to square of the medians of similar triangles. Okay, in this way you have to solve question number 6. Now question number 7. Prove that the area of an equilateral triangle described on one side of the square is equal to the half of the area of the equilateral triangle described on of its diagonal. Okay, so let's check the figure first of all. Okay, here is the figure. As you can see, this ABCD is a square. Okay, now you have to draw an equilateral triangle where suppose this ABE is an equilateral triangle where these sides are equal to the side of a square. Okay, AB is the side of square. Okay, and this EB and AE also of equal length. Okay, that means this ABE equilateral triangle is described on the side of the square. But if you look at DBF triangle, as you can see in this equilateral triangle, one side is BD. Okay, that means if this one is BD, this BD is the diagonal of the square. Okay, that means this equilateral triangle and these three sides are equal, right? These three sides are equal. So you can say that this DBF triangle is described on the diagonal of the square. Okay, now if you consider the side of the square as A, okay, if you consider the side of the square as A, then diagonal is A root 2. Diagonal is A root 2. You know, in a square the length of the diagonal is A root 2 if the sides are given as A. Okay, so ABCD is a square of sides A unit. Diagonal is 2 root 2 A unit. Okay, now if you take AB, also given that triangles formed on the side and the diagonal are ABE triangle and DBF triangle. I told you this one. Okay, so for AB E triangle, if this side is A, that means this side is also A, this side is also A. Okay, and for BDF triangle, for BDF triangle, if BD side is A root 2, then BF is also A root 2 and DF is also A root 2. Okay, the length of each side of the triangle ABE is A root 2 A unit, and the length of each side of DEF is root 2 A unit. Okay, now since they are equilateral angles, so each angle will be 60 degree. Okay, that means you can say that by AAA similarity, triangle ABE is similar with triangle DEF, because for these two triangles each angle will be 60 degree, so you can equal each other. Okay, and you can say that triangle ABE is similar with triangle DEF. So by the area theorem you can state that area of ABC by area of DEF is equal to square of its ratio of its corresponding side. So area of ABC by area of DEF is equal to, here the length of the corresponding sides are A by root 2A. Okay, so the square of ratio of corresponding side will be A by root 2A whole square. Okay, this A and A will cancel to each other, and if you apply the square, the value will be 1 by 2. Okay, that means the ratio of ABC by the ratio of, it will be not ABC, the ratio of ABE. Okay, so the ratio of ABE by ratio of area of DEF is equals to BDF is equal to 1 by 2. Now question number 8. Triangle ABC and triangle BDE, this triangle, are equilateral triangles such that D is the midpoint of BC. Okay, ratio of area of triangle ABC and BDE is, there is 4 options given, you have to find which option will be correct. Okay, if you look at the figure, since they are equilateral triangle given, ABC and BED are equilateral triangle given, that means each angle will be 60 degree as given in the figure. So since each angle is 60 degrees, so you can say that their corresponding angles are equal to each other. That means these two triangles will be similar to each other. Okay, here both triangles are equilateral, so the angles will be 60 degree. That's why by using AAA similarity, BCA will be similar with BDE. Okay, now if you consider the side of triangle ABC as X, okay, and D is the midpoint of BC, that means it will be BD length will be X by 2. Okay, now since BD is X by 2, that means this is also X by 2, because BDE is an equilateral triangle, this is also X by 2. Okay, so therefore ratio of ABC by ratio of BDE is equal to, since they are similar, is equal to X by 2 whole square. Okay, it is equal to the square of the ratio of the corresponding sides, and the length of the corresponding sides are given as X and X by 2 respectively. That's why area of ABC by area of BDE is equal to X by 2 whole square. Okay, if you solve this ratio, the answer will be 4 by 1. Okay, so the ratio is 4:1. So if you check this slide, so the correct option will be option number C. Okay, now question number 9. Sides of two similar triangles are in the ratio 4:9. Area of this triangle are of the ratio 2:3, 4:9, 81:16, or 16:81. Okay, we know that the ratio of area of similar triangle is equal to the ratio of square of their corresponding side. Okay, so ratio of area of two triangles is equal to square of their corresponding sides, ratio of square of their corresponding sides. already ratio of their corresponding sides is given, and that is 4 by 9. That means I have to do the square of this ratio. Okay, that means the ratio of area of two triangle will be 4 by 9 whole square, that is 60 by 81. So the option number D will be correct. Okay, what I said, the ratio of the corresponding sides is already given as 4 by 9, and by this statement you can say that ratio of area is equal to square of ratio of corresponding side, that means square of this ratio. Okay, so that's why I am getting this 16 by 81. So the ratio of area of triangle will be 16:81. Okay, so this is all for today. Thank you.